Welcome to the deep dive. We're here to cut through the noise and, get straight to the insights that really matter. Today, we're looking at something pretty fascinating in the world of AI large language models, LLMs. We've all seen them do amazing things, right? Writing text, answering questions, even coding. But what happens when you give an LLM a really tough assignment, like generating a full-on comprehensive research report, something that takes human experts ages?
Yeah, that's a great starting point because it's not quite as simple as just feeding it a prompt and getting back a perfect long report. We're seeing these deep research agents powered by LLMs evolving incredibly quickly. But there's also a performance bottleneck. They kind of plateau when it comes to these really complex long-form reports.
Why is that?
Well, a lot of the typical methods, they don't really have a design that's deliberately based on how humans actually research and write, the messy iterative process we go through. They might be great at finding facts, but pulling it all together into a long, coherent narrative, that's a whole different ballgame.
Okay, so that sets the stage perfectly for what we're digging into today. It's a new framework that sounds like a real step forward. The Test-Time Diffusion Deep Researcher, TTD-DR for short. And the core idea, as you mentioned, is that it's inspired by how humans actually do research. It's all about those cycles, searching, thinking, drafting, and then going back and refining again and again.
That's the heart of it. So our mission in this deep dive is to really unpack how TTD-DR works. How does it mimic that human research flow? We'll look at the clever mechanisms it uses to keep improving its own output, sort of evolving the report as it goes. And we'll see why it's getting state-of-the-art results on some really tough research tasks, how it sorts through all that information overload to give you something comprehensive and, importantly, coherent.
Okay, let's get into it then. The fundamental idea behind TTD-DR, it's not just about more compute, is it? Or bigger models. It's about looking at us, at humans. How do we tackle a big research project?
All right, think about it yourself. If you have to write about something complex, you don't just, type from the first word to the last and hit send.
Definitely not. I'd probably start with some kind of outline, maybe jot down some key points, then start writing sections, realize I've missed something crucial, go search for more info, maybe rewrite a paragraph, sometimes even shuffle whole sections around.
Yeah, what's really interesting is that cognitive science backs this up. Studies show human writing isn't linear. It usually involves setting up some high-level plan first.
Like an outline.
Yeah, like an outline. Then you draft based on that plan. But the crucial part is engaging in multiple revision cycles. And during those revisions, writers actively look for more information, maybe search databases, find new sources to back up their points or fill in gaps.
It's a recursive process. You loop back.
It is. It can feel a bit messy sometimes, but it's effective. So TTD-DR tries to model this. It thinks about generating a research report as I call it a diffusion process.
Yeah. Okay, diffusion process. That sounds a bit technical. What does that mean in this context?
It's really an analogy. Think about diffusion models in image generation. You start with random noise, right? And then iteratively refine it, step by step, denoising it until a clear image emerges.
Ah, okay, so cleaning up the noise.
Kind of like that. TTD-DR applies that idea to writing a report. You start with maybe a rough, noisy initial draft or concept, and then you iteratively refine it, adding detail, correcting things, making it clear, is denoising it into a high-quality final report. It mirrors that human cognitive pattern of gradual refinement.
Got it. So it's like sculpting, starting with a rough block and gradually bringing out the detail.
It's a good way to think about it. And to do this sculpting, TTD-DR has a core structure, a sort of foundational workflow. They call it the backbone deep research agent. It works in 3 main stages, which feel quite human-like.
All right, let's walk through those stages.
Okay, stage 1 is research plan generation. Based on your initial query, the user's question, it generates a structured plan, an outline, essentially. It identifies the key topics and subtopics that need to be covered in the final report. This serves as the initial scaffold, the blueprint for everything that follows.
Makes sense. You need a plan before you start digging. So once you have that plan, what's next? Does it just start writing?
Not quite yet. Stage 2 is where the heavy lifting of research happens. It's called iterative search and synthesis. And this is a loop.
A loop?
Yeah, first, stage 2A, it formulates a specific search question. This question is based on the plan and whatever information it's gathered so far. Then, stage 2B, it searches through relevant documents to find information for that question. And importantly, it doesn't just dump raw data. It synthesizes a summarized answer from what it finds.
So it's already processing the information at this stage.
Right. And this loop, formulate question, search, synthesize, answer, continues. It keeps going until the whole research plan is covered, or maybe it hits a preset limit on iterations. It ensures all parts of the blueprint get the info they need.
Okay, plan generated, research done through this iterative loop. Now we must be ready for the final report.
Now we are. Stage 3 is final report generation. It takes everything gathered the initial research plan from stage 1 and all those synthesized question-answer pairs from the loop in stage 2 and knits them together. It synthesizes all that structured information into the final output, a comprehensive, coherent report that directly addresses the user's original query.
Okay, so that backbone process plan, research loop, final report sounds logical. It mimics a structured human approach. But you said TTD-DR does more than just follow steps linearly.
It does. The backbone is solid. But the real magic, arguably, comes from two additional mechanisms that work together to enhance this whole process. These are designed to tackle limitations you see in other agents. Sometimes, simpler linear or parallel approaches can lose information along the way, or the end of the report might not quite connect with the beginning. TTD-DR tries to avoid that.
Right, maintaining that global context and coherence. What's the first mechanism?
It's called component-wise self-evolution. It sounds a bit fancy, maybe, but the idea is actually quite elegant.
Go on.
Instead of only trying to improve the final report right at the end, TTD-DR applies a kind of self-improvement process, like a mini evolutionary algorithm, to each individual part of the workflow.
Each part. So like the plan itself can evolve, the questions it asks.
Exactly. The plan, the search questions it generates, the summarized answers it synthesizes, even early drafts of the report, they can all go through their own optimization cycle.
How does that work in practice?
Okay, let's say the agent needs to generate an answer based on its search results. Instead of just writing one answer, it generates several different versions, diverse variants of that answer. Then it uses another LLM, configured as an LLM as a judge, to evaluate these different versions. This judge provides scores, critiques, feedback on things like accuracy and clarity.
Like having a built-in editor reviewing multiple drafts of just one component.
Kind of, yeah. Based on that feedback, the variants are revised, sometimes iteratively. And finally, the best revised versions are intelligently merged together into one high-quality output for that specific component. Doing this for every piece, the plan, the questions, the answers, ensures that the building blocks going into the final report are already really strong and refined. It catches weaknesses early.
That sounds powerful, optimizing every little piece along the way. What's the second mechanism?
The second one is report-level denoising with retrieval. This is where that diffusion or denoising idea we talked about earlier really comes into play for the entire report.
Okay, so moving beyond just the components to the whole document.
Right. It starts with an early preliminary draft of the report. This draft might be incomplete, a bit rough, you could call it noisy. But this draft isn't static. It serves as an updatable skeleton. And it gets iteratively refined through that denoising process.
How does the retrieval part fit in?
That's the key. At each refinement step, the denoising isn't just happening in isolation. It's dynamically informed by a retrieval mechanism that pulls in external information as needed. And here's the really clever feedback loop. The current state of the evolving draft actually helps guide what the next search query should be.
So the draft itself is saying, I seem to be missing information on this specific point.
Pretty much. The draft guides the search. Then, the new information found in that search is immediately used to revise and improve the draft. It's this continuous cycle. Draft guides search, search refines draft. This design makes the whole writing process much more timely and coherent. Information gets integrated right when it's needed, reducing the chance of losing important details or context, which can happen in more step-by-step methods.
Okay, so you have this backbone structure mimicking human research, and then these two powerful mechanisms layered on top. Optimizing each individual component through self-evolution, and continuously refining the whole report draft using guided retrieval. It sounds very thorough, very iterative. The big question then is, does it work? How does TTD-DR actually perform?
Well, the results reported are quite strong. TTD-DR seems to achieve state-of-the-art performance on a range of benchmarks, especially those needing deep search and what's called multi-hop reasoning, where you need to connect several pieces of information.
Any specific example?
Yeah, for those tasks demanding long, comprehensive research reports, which, as we said, are tough. They tested it on datasets like long-form research and deep consult. In head-to-head comparisons against OpenAI Deep Research, TTD-DR reportedly achieved win rates of 69.1% and 74.5%, respectively.
Hmm.
These are tasks like summarizing new scientific papers for a professional or analyzing complex geopolitical events.
Those win rates sound significant, and it wasn't just about getting an answer, but the quality.
That seems to be the key takeaway. The evaluations indicated that TTD-DR's reports were often judged as more helpful and more comprehensive.
How did they measure helpful and comprehensive? That can be subjective.
They used that LLM as a judge approach again, but calibrated based on human preferences. The judge assessed outputs using metrics like helpfulness, did it satisfy the user's intent, was it easy to understand, accurate, well-written, and comprehensiveness, did it miss any key information. These metrics, along with the direct side-by-side comparisons, pointed towards TTD-DR having a qualitative advantage in many cases.
What about efficiency? All this iteration, self-evolution, denoising.
Yeah,
Does it take a lot more computational power?
that's a fair point. The analysis in the research suggests that while it is an iterative process, the two main mechanisms, self-evolution and denoising with retrieval, provide significant performance jumps for the computational cost involved. It's more about the value you get from the computation. The self-evolution boosts the quality and diversity of the information gathered right from the start. You're working with better raw materials, so to speak. And the denoising with a retrieval makes sure that information gets integrated efficiently and effectively into the report as it's being built. Remember that example where by step 9, it had already incorporated over half the final report's info?
Right, showing it integrates info early and doesn't wait until the very end.
So it seems designed to deliver that higher quality and coherence without necessarily causing a runaway increase in computational demands compared to the value it adds. It's an integrated efficiency.
Okay, so summing up. We've explored the Test-Time Diffusion Deep Researcher, TTD-DR. It's a framework that takes a different path from many LLM approaches. It really leans into mimicking how humans research that iterative, reflective process. It uses a draft-centric design, constantly refining.
And it powers that refinement with those two key mechanisms. Component-wise self-evolution, making sure every building block is strong.
And report-level denoising with retrieval, ensuring the whole report evolves coherently with timely information.
Leading to reports that are not just accurate, but also highly coherent and comprehensive, achieving state-of-the-art results on difficult tasks.
It really highlights how looking closely at human cognition, our own strategies for tackling complexity, can inspire genuinely new directions in AI development.
Absolutely. It shows that carefully designed iterative processes, inspired by how we think and work, can unlock surprising capabilities in these systems.
Which leaves us with a thought to ponder. If modeling this kind of complex human behavior, the drafting, the revising, the constant feedback loops can lead to breakthroughs like TTD-DR for research reports, where else might this approach take us? How might mimicking other sophisticated human cognitive processes continue to redefine what AI agents can achieve in the complex, messy, real world?